In this example, we'll be looking at a word problem involving a radioactive isotope. So please take a moment to pause the video and read the question. Now that you've read the question, you see that we're given a function in the problem, and that function is a of t is equal to the initial amount, and then we have a half-life, and again, the t and the h of the time that we're looking for versus the half-life. So in this problem, we've got to identify what each of these unknowns is in this context. So we know the half-life of the radioactive isotope is 30 hours. So that would mean that h is equal to 30. So let's write that down. H is equal to 30. We also know that the initial amount is 1,792 milligrams. That's the A0 one there. 1,792. And what I'm looking for is how long will it take to decay to 56. So in this case, A of t, that final amount, is 56. So the unknown that I want to find here is t, because it's asking me how long this process is going to take. So I'm going to fill in those values now in the equation I'm given above. So that will give me 56 is equal to 1,792 times 1/2 to the t over 30. Now, the only method we know to solve an exponential equation right now is to solve using like bases. So in order to get to that point, what I'd like to do is, first of all, take 1,792 and move it to the left-hand side. So I'm going to divide both sides by 1,792. So that means that they're going to cancel on this side. And I've got 1/2 to the t over 30. Now, a useful strategy for simplifying the left-hand side here, as opposed to trying to find something common that divides in the top and the bottom, or ending up with a decimal answer, would be to take 1,792 and divide that by 56. If I do that, I'm going to find I get a value of 32. So what that means is that this side of my equation will simplify to 1 over 32. So now I know that I can write 32 as a power of 2. So that's going to give me 1 over 2 to the exponent of 5 is equal to 1 over 2 to the exponent t over 30. So now that I've got a common base, I can equate my exponents. So I can say that 5 equals t over 30. Now since I'd like to solve for t, I'd like to multiply both sides of this expression by 30, meaning those will cancel on this side, and I'll obtain a time of 5 times 30, or 150 for t. Referring back to the problem, time is given in hours, so when they ask me how long would it take to decay, it's going to take 150 hours.